Okay, in chemistry BandAid number 2, I need to introduce something called isotopes. I'll explain, I'll give you some examples, and your takeaway from this is that there are heavy and light isotopes. I'll give you some examples, then we'll move on to other stuff that gets us closer to the atomic energy stuff, okay? Remember that the number of protons tells you what element you have, and the number of electrons tells you the charge and thus the bonding behavior. But all of that is chemistry for babies. That's what you would need for Chemistry 101. But we're not really here for Chemistry number 101. We're not trying to do bonding stuff. We're not trying to do like ions and stuff. What we're trying to do here is we're trying to get you up to nuclear physics level. In nuclear physics, we really don't care about the number of protons and the number of electrons, not really. What we really want to know is what's happening inside the nucleus. That's why it's called nuclear. And what's interesting is the neutrons, actually. Neutrons are just dead weight. They're just mass. They don't have a charge. And so technically, an atom could lose a neutron and still behave the same way in terms of bonding and stuff. It would just be a little lighter. And while an atom is bobbing around the universe, if it happens to smash into a neutron, it would just be dead weight. It's just baggage. Somebody ever hand you something and you put it in your car and you forget about it? Neutrons. So you could take an oxygen, throw a neutron at it, and that's really just gonna like sit in the nucleus. It's just like, now I'm a heavy oxygen. And you know, the universe is a complicated place. There's a lot of energy and a lot of forces. And so out in the universe, atoms get manipulated all the time. They lose neutrons and they gain neutrons. That happens pretty commonly. And we say that they could be light if they've lost or heavy if they've gained neutrons. And those different versions are called isotopes. Heavy or a light version of an element. So you can have a light carbon. That's just a carbon that's lost a neutron. It has one less than usual. That'd be light carbon. And you can have heavy carbon. That would just have more neutrons than usual. As a matter of fact, you can have one heavy carbon or two heavy carbon because it's gained one extra or two extra. So those are the isotopes of carbon, the ones that are common on Earth. Carbon-12 is the majority of carbon, but some carbons weigh 13 because they have an extra neutron, and some carbons weigh 14 because they have two extra neutrons. This isn't supposed to be complicated. It's just a lot of words you don't use. So there's no like secrets here. Just replay that if you didn't hear me. You can be a little heavy or a lot heavy. That would be carbon-12 is the same, 6 and 6. Carbon-13 is 6 protons plus a 7th neutron, right? 6 plus 7 is 13, carbon-13. And you can even have carbon-14. It's the same number of protons because it's still carbon, but you know, it's gained a few extra neutrons. You can also do this with hydrogen. You can have regular hydrogen, which has no neutrons. Deuterium, which is hydrogen 2 because now it has a neutron. Or tritium, which is hydrogen 3 because it has that one proton that makes it the hydrogen, plus now it has 2 neutrons. Isotopes. That's all we got to do is just isotopes. The idea that you can be heavy or light by changing the number of neutrons. I'm going to pause. We'll be back.